everyone, welcome to my channel Master Mathematics by Shaiji Mohandas. Today we are going to learn about the midpoint theorem, that is the class 9 chapter 8 quadrilateral. The midpoint theorem is very important. You will get a 3 marks. Okay, it is a sure question in your board examination. Okay, let us see how to prove the midpoint theorem. Okay. So here BD is parallel to CF. So BD is parallel to CF means this is the opposite sides of the parallelogram. The statement, the theorem says that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is equal to half of it. This is the theorem. Let us see how to prove it. Okay, the theorem says that the midpoints of any two sides of a triangle. So see, this is a triangle. Okay, in this triangle we want to find the midpoint. How to find it? Listen, this is the A, B, C. Okay, this is A and this is B, this is A, this is B and this is C. These are the A, B, C. This is a triangle. Okay. In this triangle we want to find the midpoint. Midpoint means we can fold it. This C and A and this A vertex and C vertex will be on the same point. So we can fold it. Okay. So this is the midpoint of AC. Okay. The next, the side is, this is AB. We can fold it. Then the A and B are same. Then this is the midpoint. Similarly, the third side, this is AC. We can fold it. Then A and B will be on the same point. This is the midpoint. Okay. So let us see here. This is the midpoint of AB and this is the midpoint of AC. So we can name it, this is D and this is E. So A, B, C. So the midpoint of the AB is D and the midpoint of AC is E. So here the theorem says the midpoint of any two sides, the line joining the midpoint of any two sides. So that this DE is parallel to BC. So DE is parallel to BC and DE is equal to half of BC. This is the theorem. Okay. So let us see here. If we are taking D and C are the midpoints, let us see here. We can fold this. So this line, this DE as we have to take it as a X. So this is X, then similarly this the midpoint, then this is also X. Okay. Then here the BC side. Okay, this is the BC side. Then again this is folding this like. So this is folding this like. This is the midpoint. So see, this line is also X now. So midpoint to the point C. So same this as X. So we can write it as here X. So what is this? DE equal to X and this is 2X. So we can prove it as DE equal to, this is 2X no. So this is half of BC. So we want to prove it as DE is parallel to BC and also DE equal to half of BC. Okay, let us see how to prove. Okay. So first we want to make a construction. So this AB, we can draw a line through C is parallel to AB. That means this is the line is parallel to AB. Then that is F. Then produce D and join to F. This line is produced to join as F. Okay. So first we have to draw through C is a parallel line of AB, that is CF, and DE produced to F. Okay. Then from here we want to prove it. These two lines are parallel. So the proof. The first is construction. Construction is draw CF parallel to AB and DE produced to F. DE produced to F. Okay, this is the construction. So for the proof, first we have to take in triangle ADE. So ADE and in triangle ADE and CEF. CEF. Triangle AD with this triangle and this triangle. We have to take it these two triangles and want to make it as a congruence. Okay. So listen here. We know D is the midpoint of AB and E is the midpoint of AC. So we can say that in these two triangles, AE equal to CE. Then AE equal to CE. Why? E is the midpoint of AC. Okay. Then next, these two angles. What is this two angles? It is vertically opposite angles. That is angle 1 and angle 2. So angle 1 equal to angle 2. That is vertically opposite angles are equal. Okay. Then next, we have to take it here. This is AD and this is C and this is F. This is A, D, C, F. See this. AD is parallel to CF. AD is parallel to CF and AC is the transversal. AC is the transversal. So AD and CF are parallel. Why? We already drawn as CF as parallel to AB. That means it is AD is parallel to CF. Then AC is a transversal. What is these two angles? That is angle 3 and angle 4 are alternative interior angles are equal. So this is angle 3 and this is angle 4. So angle 3 and 4 are alternative interior angles are equal. So we can write it as angle 3 equal to angle 4. That is IA alternative interior angles. Why? That is AD is parallel to CF and AC is the transversal. AC is the transversal. Okay. So now we conclude that one side, two angles. One side and two angles. What is the congruency? ASA. So we can write as triangle ADE is congruent to triangle CEF by ASA congruency. So we know if any two triangles are congruent, we can write it all the corresponding parts are equal. So what is here CPCT? So DE equal to EF. DE equal to EF. And also we can write it as AD equal to CF. AD equal to CF. Both 1 and 2 are CPCT. Corresponding parts of the triangles are congruent. Okay. So now we conclude DE equal to EF and AD equal to CF. Okay. Now we got it. DE equal to EF and AD equal to CF as a CPCT. Now we can write that from figure. D is the midpoint of AB now. So we can write as AD equal to BD. So AD equal to BD as equation number 3. So see here. This left side are AD and right side CF and BD. So from 2 and 3 we can write it as here CBD is parallel to BD is equal to CF. So BD is equal to CF. We already know what is that. That is AD is parallel to CF, then BD is parallel to CF. So BD is parallel to CF. Let us see. So BD is parallel to CF. So in this figure, BD is parallel to CF means it is the opposite sides. So BD is parallel and equal to CF means we can say that DBCF is a parallelogram. DBCF is a parallelogram. So DBCF is a parallelogram. Okay. So if DBCF is a parallelogram means we can say that the opposite side, another pair of opposite side also equal and parallel. So what is the other side? DF and BC. So we can write it as DF is parallel to BC and DF is equal to BC. Okay. We know, we already proved what is DF. DE equal to EF. So DE equal to EF from 1. So from 1 we already proved that is the corresponding sides of the two congruent triangles. So corresponding sides of the two congruent triangles DE equal to EF. So we can write it as DF equal to, we can say DE plus EF. DE plus EF, both are equal. So we can write it as DF equal to 2DE. So we can substitute here. So in place of DF, we can write it as 2DE equal to BC. So what is next? So DE equal to half of BC. So now we proved here DF is equal to BC. Then we can write it as here 2DE equal to BC means this is DE is parallel to BC. So we proved the first one and also DE is equal to half of BC. Is it clear? Okay. Where this midpoint theorem is applicable to in the day-to-day life. Let us see. For example, an architect want to make a triangular window. So this is a triangular window. Okay, an architect want to make a triangular window. For the window, the lower half will be made up of glass. Okay, for the lower half will be made up of the glass and upper half will be made with the bamboo stick. The question is this: how much maximum length he need to make this triangular window? Okay, so listen here. This is the triangle ABC. The base is 20 meter. How much maximum length of bamboo sticks we need to make this triangular window? Okay, so now listen here. This is the midpoint of AB and this is the midpoint of AC. So from the midpoint we are moving away from the midline segment towards the vertex. The length will be decreasing and from the mid segment going to the lower half it will be increasing, isn't it? So here this is the maximum length. D is the maximum length of the bamboo stick. Okay. So we know using midpoint theorem then D equal to the half of the base, that is BC. So what is the length? 20. So that is equal to half of 20, that is equal to 10 meters. So how much maximum length we need to make this triangular window? That is 10 meter. Is it clear? So this is the application problem of the midpoint. What is the midpoint theorem? That means if the midpoint, the line segment joining the midpoint of any two sides of the triangle is parallel to the third side and also equal to the half of it. Is it clear? Okay, so next we are moving on to the 8.2, the first problem based on the midpoint theorem. Let us see here. Here it is given the question. This is the first question of the 8.2. It is given as ABCD is a quadrilateral and PQRS are the midpoints of the AB, BC, CD and DA respectively. Okay. We want to prove SR is parallel to AC and SR equal to half of AC and PQ equal to SR and PQRS is a parallelogram. Okay. So if PQRS is a parallelogram means we want to prove it opposite sides are equal and parallel. Let us see how to do. The first one, so listen here, this AC is the diagonal. So we can take it as ADC as a triangle. So in triangle ADC, in triangle ADC, then AC is the diagonal. AC is the diagonal. Then listen, so ADC, this is the base, then this is the midpoint. S is the midpoint of AD and R is the midpoint of S. Then line joining the midpoint is parallel to the third side. So this is the ADC. This is D, this is A, this is C. So the midpoint is joining. This is S and R. This is joining. So what is the midpoint theorem? This SR is parallel to AC. SR is parallel to AC. And also it is half of it. So we can write it as SR equal to half of AC. It is very easy. Okay. Next, this as equation number 1. Next, for the next PQ equal to SR. For that we want to take the triangle ACB. So this is AC, this is B. So this is the ACB. For the AC is the base and for the AB midpoint, that is P, and this is the midpoint, this is Q. So the line join the midpoint PQ is parallel to AC. So we can write it as PQ is parallel to AC and also it is half of it. So PQ is equal to half of AC. That is equation number 2. So listen, from 1 and 2, the right side are equal, then the left side will be equal, because here SR is parallel to AC and this SR equal to half of AC, and here PQ is parallel to AC and PQ is equal to half of AC. From 1 and 2, this SR is parallel to AC and PQ is parallel to AC. We can write it as SR is parallel to PQ. And this will be cancelled and SR equal to PQ. The second question will be finished. So PQ equal to SR. Next, we want to prove it PQRS is a parallelogram. If the PQRS is a parallelogram means we want to prove it the opposite sides are equal and parallel. So listen, PQ and SR the opposite sides. Is it clear? PQ and SR is opposite sides are equal and parallel. Then we can write it as parallelogram. That is PQRS is a parallelogram. It is very easy and simple. Got it? Okay, so it is the midpoint theorem. Midpoint theorem says that the line segment joining the midpoint of any two sides of a triangle is parallel to the third side and is equal to half of it. So here AC is the third side of the ADC, then SR is parallel to AC. Similarly, the PQ is the midpoint joining the two sides, then PQ is parallel to AC. That also, if this is parallel to here, this is parallel to here, always we can say that SR is parallel to PQ and also that are equal. So the opposite sides are equal and parallel, then it will be a parallelogram. Okay, got it? Thank you so much for watching. See you soon on my next video. Till then, bye.